Well, hi everyone, my name is Natalie and today I will be presenting my thesis project. Before I start, I would just want to give a quick overview of the entire project. So in this project, I utilize self-modeling networks, also known as adaptive networks, and I want to stimulate the effects of organizational culture, specifically on mistake handling and how different cultures have different mistake tolerance environments and how can that influence organizational learning, and in turn it can influence its performance. So this is just a brief overview of table of contents for today. Before I get started about how exactly the methodology, I'll give some relevant background literature. So the project itself is based on the competing values framework developed by Cameron and Quinn. This framework is an instrument used to categorize different organizations into types of cultures, and it's based on two dimensions, as you see: flexibility and discretion, and external focus or internal focus. So by these two dimensions, 4 clusters are created where different organizations can be categorized. Clan, for instance, has very high flexibility and it's really internally driven, which means they're focused on the progress within the organization versus in juxtaposition to other organizations, which is more like market type cultures, as you see on the bottom right quadrant. That means they are focused more on rivalry and more on competing with other organizations. So in this project, the cultures are defined on these two different dimensions of flexibility and positioning, where flexibility ranges from high flexibility or more durability and firmness on the other end, while positioning also is synonymous with the internal and external positioning. It ranges from being more internally focused or externally focused. And this gives rise to a flexibility of defining different cultures using different values of these two dimensions. Extending to that, leadership is also important, especially transformational leadership qualities, which can extend to leadership empowerment behavior, such as reinforcement, delegation, and coaching. These are all important behaviors which can enhance or motivate the learners into learning more and better quality. And beyond that, there's also other traits of leadership that are quite important, such as status and consistency, which can really influence the attention and the learning of the individual. And as for learning, organizational learning in this scope refers to individual learning, but also team learning, which is based on the individual learning. And for the individual learning, it's mainly based on vicarious learning, which has 3 distinct stages, as you see. First, there's observation, where the learner uses the attention and observes the behavior and therefore achieve retention, which is memorizing the pattern observes. And then there's the imitation phase, which mirrors the model's behavior. And then finally, the participation phase, where you see the fully produced behavior. So all these distinct stages can be modeled through Hebbian learning, which is based on Donald Hebb's famous theory, explaining the neuroscientific approach towards vicarious learning. A little explanation here about the Hebbian learning theory. It presumes that neurons that fire together wire together. That's the famous mnemonic to explain it. But it pretty much focuses on how one neuron that's persistently involved in firing elicits changes in one or both neurons. And this is the basis of the theory used to model learning behavior on an individual level and then on a shared level through the individual learning. So I'll quickly go over the methodology and the network approach used. As you see here, the self-modeling network approach, this is a little explanation before showing the final model because it's a little complex. As you see here, there's a base level which represents the real world. And then through higher level planes, you can model network characteristics on the base level. Similarly, you can add higher plane levels, such as this third plane, to model and adapt other characteristics. So the middle plane right here represents different states and characteristics of the actual model. And that way, this facilitates not only adaptation of the model itself, but also control of adaptation through higher level planes. And this notion will be used in this project to control the adaptation of learning and the culture, and so on. The input of the computing environment takes into different role matrices, both adaptive and non-adaptive matrices, where you specify the base connectivity to other nodes, the connection weights, speed factors, and the combination function weights, which specifically decide like how the different connection weights aggregate onto the states, and then the parameters. So for each one of these role matrices, there's also an adaptive counterpart. And this is the basis of the computing environment used for the model. Before I show the model, I wanna provide the hypotheses and the conceptual model so it's more clear. I'll mainly focus on how higher flexibility and discretion can have better organizational learning, and that the culture and the leader behavior must be aligned to achieve best learning effects, that is with higher consistency and higher status. This is the base conceptual model where you can see how the company culture, especially in relation to mistake tolerance, can affect the leader, both the status, the consistency, and empowerment behavior, and thus in turn affects the individual learning process, which is the basis for the team learning. You can see how there's different phases, and this is the base conceptual model for the final model used, which is this. And it can be a little bit overwhelming at first, but I will break it down a little bit now. As you see here, these oval encapsulations, they represent mental models of tasks for individuals, where they have input from world observations as well. And then the bottom one is the leader mental model of these tasks. So the individuals have input from the leader and also from different interactions with the leader, which can affect the attention at the base level. And in the middle over here, there's different characteristics of the leader, such as status, consistency, and also the culture in the light purple. And as you see here, it might be a little bit unclear, but there's dotted lines again for the last state, and that represents where the mistake happens. So that can influence the mistake recognition state, and in turn the mistake management, so which is influenced by the culture. So depending on the culture, the light purple, the mistake tolerance or mistake handling can be affected. And as you see on the first level plane, but also the middle level plane, you can see the yellow nodes represents attention to world states, and the purple ones are attention to the leader, which is influenced by status and consistency. And then the pink nodes towards the sides represents the individual learning, which can influence the shared learning in the middle, as you see here. And they influence base level states of this parallelogram, which is the shared mental model. And for the final level plane, there are adaptive factors that control the learning loops, that is both feed forward and feedback learning, with feed forward learning being towards the organization, and feedback learning towards individuals, and also from organization to team level. So this controls the adaptation of these learning loops, and also reinforcement of the individual learning by modeling persistence of Hebbian learning, as you see here by the pink nodes, which represents Hebbian learning. Simulation results analysis. What I did is I converted the files into data frames and split them into 3 dependent variables. That is mistake tolerance, mistake handling, that is, and individual learning and team learning. And then a collection of different comparisons using Wilcoxon rank sum test was carried out, and a total of 54 comparisons were collected and stored. And I will go over the simulation results first and then discuss the statistical analysis. Before I start, I just want to give temporal context into the actual simulation. As you see here, it's structured in a way where there are 2 rounds almost of both interaction and then the learning loops. So the interaction with the leader and the learner takes place, which is followed by feedback learning. Very shortly after, you have feed-forward learning. And then another round takes place with another interaction. And this way it can facilitate also transitions of cultures, and you can see distinctly the effect of each culture on these dependent variables. Here's a brief overview of the results. This is with high consistency and high status. You can see that for each culture, there is a gradual increasing effect. With higher flexibility and internal positioning, the results are much higher versus hierarchy, which has the lowest flexibility and a high positioning. You can see much lower. Along the same line, you can see the same expected results with low consistency and low status of the leader. For the different cultures, it shows a gradual decreasing effect the more you go towards more control and less mistake tolerant environment. So this is clan, adhocracy, market, and hierarchy, where this is the highest and this is the lowest. This also shows a transition from one culture to another with high status and consistency. You can see here from the beginning till the middle time point, there's a hierarchy, existing culture, and then it transitions to clan, where there's much better mistake handling and individual and team learning. Shows also when only one of the status or inconsistency is high, and this shows exactly the same results, demonstrating how both status and consistency are equally important in leader traits. As for the results of the statistical comparisons, all results were in line with the hypothesis. So comparisons between each culture when there's high status and consistency all demonstrated to be statistically significant, similarly to when there's low status and low consistency. And there was also non-statistically significant result, but was in line as well with the hypothesis, because this is high status and low consistency and low status and high consistency. So between the same culture comparisons, there was no statistical difference, which shows how, as I said before, both are equally important and serve a role in learning. Similarly, when one of the leader traits is low and in comparison with when both are low, there is insignificant results with market comparisons, but only in regards for team learning. And this shows the same thing. And therefore, the final conclusions about the different dependent variables, individual learning and mistake handling both showed very vivid, statistically significant results, both in the simulation results, but also in the statistical comparisons. Same for team learning, depending on the leader traits. And in general, this shows how organizational culture can really influence the mistake handling and learning process of individuals and their attention. So how more mistake tolerant environments and cultures like clan and ad hoc cultures can really foster a more healthy environment for learning. And this simulation basis can offer a really flexible framework for future research, delving more into context factors about organization that can take into account the size of the organization and more leader traits and frameworks to consider. So that can facilitate a lot more future research based on this. Thank you so much for listening. If you would like to have any questions or to go over anything else, please don't hesitate. Thank you.